Hi, today we're gonna talk about this question. I think this is question has a few concepts in it, and there is one twist in that question I want to emphasize on it, and I highlighted two I think important part in this clinical vignette. Now the question says a group of investigators, they were trying a drug, and they comparing placebo to control for specific disease. Now here's the twist. Start from here. It says that the primary outcome was all-cause mortality. You need to know what does that mean. All-cause mortality means all dead people, like in a flat expression. Then it say a decrease in all-cause mortality in treatment group was reported with a relative risk of 0.71 with p-value this much. Which of the following statement is the best interpretation of the reported association? Now you can pause the video and pick your answer, and I will explain why the right or correct answer would be that specific point or specific choice. Before we go in that depth, maybe you know or you don't know what does it mean, relative risk. Relative risk basically is people who are exposed to specific disease or risk factor. So here is people who are exposed over here, over people who are unexposed, and you will have diseased people or diseased people over with undiseased people. This is a typical box that's you're gonna see all the time. So relative risk is A over A plus P over divided by C or divided by C plus D. Now from the box you have in your equation B, okay, and as well you have D. So do you think this specific equation would only count the true positive, or people who are truly diseased to people or exposed to people who are unexposed? Of course not. You are included B and D, which are people who can be true negative or could be false positive or false negative. So it's not 100% and a correct way of calculation of your risk or relative risk. So on that premise, on that equation, relative risk can be defined as let me pull that part in the screen. It's a point of estimate association, but it does not count for random error, because you're gonna include people who have or did not have the exposure. It's always possible on that premise that a calculated relative risk occurred by chance. So you could, whatever association you were looking for, it could come very strong, but again, that could happen by chance. That being said, I hope that explained in brief relative risk. Now something else I want to talk about is the p-value. Now p-value, what is a p-value? P-value, it's basically a pre-calculated computerized value. It's let me give you an example. Let's say that you have you are trying to find the association between people who are smoking, your exposure is smoking, and lung cancer. So you found people who smoked have very high percentage of lung cancer, okay, and people who did not smoke, they have either no or very small number of lung cancer, okay. Now you want to try to prove it but you will have a committee or people from the other side saying, well, probably you calculated that by chance. And these people or this party usually called null hypothesis. You can assume these people as the Republican trying to defeat and go against the Democrats. Now, what is it the one that will give the final word? It's the p-value. If the p-value is, you have to know, if the p-value is smaller, more it's powerful. Again, p-value is smaller, less than 0.005, that means your study is strong. So if p-value was of this specific study was 0.001, that means your study is strong and Republican will lose. Okay. So that's explained. I wish that you retain that concept. Small p-value. Small p-value means strong association or strong study. Then you're gonna reject the null hypothesis. Let's apply that on our question. Okay. Now, here it says that the primary outcome was all-cause mortality. Now, you have to remember, you have to pick up or you have to recognize where's the null hypothesis here. The null hypothesis here in the green highlighted, it's trying to tell you that the null hypothesis trying to undermine your outcome. And the part in highlight here is saying that the all-cause mortality, that means all dead people in treatment group, was reported, right? So the percentage of all dead people was 0.71. It's like out of 100, let's say 71 people died because they were treated. Remember, this is how much people died in comparison to not exposed people. How did I know? Because it told me here all cause mortality, all people who were dead in treatment group was reported. On that premise, let's read the choices, our choices. So here it says that the 95 confidence interval for relative risk of all-cause mortality includes 0, 1, 0. Well, first of all, it did not mention confidence interval, so it did not. Confidence interval usually give you two numbers from 1 to 3, let's say, and it would tell you like, and you tell you that your number is falling in that range, and would give you that confidence interval, but it did not mention it here. So this is cannot be the answer as well. The p-value is less than 0 or it's equal 0.001. Here it's telling you 1. It has no significance. Remember, p-value should be less than 0.05. B, there is a 1.1 percentage. Look, here it's trying to manipulate this number. It's the same number as 0.001. So it's the same number as here. The probability of observing the given relative risk or more extreme by chance alone, assuming no difference in mortality. So here here the choice B, it says that well, there is a 0.1 means 0.1 percentage means this number. Okay, probability of, saying probability means p-value. Okay, this is the p-value of the given relative risk by chance alone. Why it says that? Because the definition of relative risk, it could be an error. It could be the result by chance alone, assuming no difference in mortality. This is the outcome. It's already said that in the question. The primary outcome was all-cause mortality. So there is no difference in the outcome, because the null hypothesis is saying, well, there is no difference in mortality if you get that specific treatment. So here that statement represents the definition of relative risk by saying by chance alone, and it's telling you the null hypothesis. So this is the closest answer to the question. Let's go through the other answers. There is 71% decrease in all-cause mortality in the new aldosterone receptor antagonist. This is the drug, okay, compared to the placebo group. Well, this is definitely incorrect. There is no decrease by 71%. This number is the relative risk of mortality rate. The how much it's lowered to that number of all cause. So this is how people died, and so the one who lived are 29%, not 71%. Okay, so this is wrong. There is only 0.1% chance that relative risk calculated is biased in favor of aldosterone. Of course not, because p-value is, if it's very, very tiny, that's mean your study has significant. The results obtained are not statistically significant. That's definitely not correct as well, so that will be excluded. The right answer is B. There is a 0.1% probability of observing the given relative risk or more extreme by chance alone, assuming no difference in mortality. I hope that explained. If you have a question, please leave it in the comment. I'll try to explain it and answer it. Bye.